In Algebra 1, we are reviewing 7.1 and 7.2. I am kind of splitting all these up. You've got the Abeka videos reference that you can go to if you need to. I know there are going to be a couple where the videos have maybe they're over 3 different lessons and you don't know which one exactly is. You're going to have to scrub through the video to try and find that because I do not have the access to the videos like you do. But I can at least tell you what lesson number we're on. But I'm going to go over greatest common factor today and how to find the greatest common factor in a polynomial. So the first thing we have is we have greatest common factor is the largest shared factor between two things. So if we look at 16 and 24, I'm going to do this by prime factorization. Okay, so 16 is 2 times 2 times 2 times 2, otherwise known as 2 to the 4th. And then 24 is 2 times 2 times 2 times 3. 2 cubed times 3. Now it has to be shared. So because it has to be shared, I can only take out the 2 cubed and I can't take out the 3 because they don't have that. So that means that 2 cubed or 8 is my largest shared factor, my greatest common factor. Now you could do this by setting it up and saying, oh, this is 1 times 16, 2 times 8, and 4 times 4. And this is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. I like doing it this way better because for some of the problems down here, it's gonna make a lot more sense. Okay, so I've got 6xy. So this is 2 times 3 times x times y. And this is going to be 2 times 2 times 3 times x squared times y squared. So see, I'm going to keep that there because again, it has to be shared. So I'm going to circle that they share this and I'm going to circle that they share that. They both also share an x and a y, but I'm going to lightly circle those because the only one that I can use are the singular x and the singular y from up top. So my greatest common factor is actually going to be 2 times 3 times x times y, which ends up being 6xy. Okay, let's move on to these. I've got 3 other examples for us. So the factors of 10 are 2 times 5 times x to the 4th. The factors of 5 is just 5 times x cubed. The factors of 20, 2 times 2 times 5 times x squared. So here I can see that they all share a 5. 10 and 20 also share 2, but because the 5 does not, I cannot use that. So I'm going to have a 5 here. And then they all do share an x as well, but I have to take out the fewest, the one with the fewest exponent. So I'm going to take out my x squared. And I have 5x squared. If I were to write this whole thing here, so this is my greatest common factor. If I wanted to rewrite this, I could write this as 5x squared times 10x squared plus 5x plus 4 plus 4. No x afterwards. So if you remember doing that, it just then you divide everything by that. All these are going to be multiple choice, so if you at least know the greatest common factor, you should be able to pick out this option if it asks you to factor fully. I'm pretty sure for this, it's just going to ask you to find the greatest common factor. Okay. Moving down here, it's very similar, but we have a negative involved. So my 8 is going to be 2 times 2 times 2 times x to the 7th, 2 times 2 times x to the 6th, and this is going to be negative 1 times 2 times 2 times 3 times x cubed. So they both share the 2 2's, and they both share an x. So I'm going to take out 2 times 2 and then my fewest exponents here, which is x cubed. So 4x cubed is my greatest common factor. You can divide it out if you want to see how that would be written, but I'm fine with what I left before. Okay, so here, if you'll notice, I've got x times a minus b minus 6 times a minus b. I split this up into my 2 separate terms, and we can see when we do this, this makes it so much easier for us to see, oh, my greatest common factor is actually a binomial, a minus b. Guess what? That is possible. Remember how last week we were dividing polynomials by monomials, and before we were factoring so that we could divide polynomials by polynomials, where you had the 2 sets of parentheses over the 2 sets of parentheses, and then it's like, oh, that one and this one are the same, you can cancel them out. This is where they get that whole concept from. It becomes greatest common factor that they can take out there. Okay, and that is all for greatest common factors.